Good afternoon everyone and welcome to my YouTube channel. So here with me we are doing some practice problems on redox reactions, the introduction to practice problems in redox reaction. So we will look at the basic things that we look at, the oxidizing agent among other things, and some calculations. So if you are new to this channel, I would urge you to like, subscribe for more so that A-level chemistry becomes a walk in the park for you. So to begin with, we need to know what the terms mean. So what is meant by an oxidizing agent? So an oxidizing agent is a substance that helps oxidize another substance but ends up being reduced. Likewise, a reducing agent is a substance that helps reduce another but ends up being oxidized. So each and every time you're looking at a substance that ends up being oxidized, then that is a reducing agent. If it ends up being reduced itself, then that is an oxidizing agent like that. So now, from our knowledge, we know to say oxidation is the loss of electrons, meaning to say the overall charge increases. Then reduction is the gain of electrons, meaning to say the charge reduces. So all you can just think is reduction, charge decreases. Oxidation, charge increases. So first reduction, charge increases. Oxidation, charge reduces. Just like that. So now we have the first question, which is in the reaction Zn plus Cu2 plus will be able to become Zn2 plus Cu. Then we're asked which species is oxidized. So the species that is oxidized is the one that ends up having a positive charge. So here Zn has become, it has lost electrons, so it has become too positive. So this one becomes your oxidizing agent. Remember what I said. For the second one, which says that in the same reaction above, the oxidizing agent. So the oxidizing agent is the one that helps oxidize another substance but ends up being reduced. So you ask yourself which one is reduced between these two. So the one that is reduced is Cu, because it has dropped from a number such as 2 positive to become a 0. So if it's not showing, then it means the overall charge there is a 0. So it has from 2 to 0, meaning to say it has been reduced. The one that is reduced is the oxidizing agent. So the answer there is, we are looking at the answer there is, which one is the oxidizing agent? So the oxidizing agent has to come from the reactants. So the answer there is C. Oh, sorry, B. So we have this one is our oxidizing agent. So looking at the next question, we have oxidation is defined as, so how do we define oxidation? So oxidation in terms of electrons gained or lost is defined as the loss of electrons. So meaning to say the answer for question 3 is B. Let's look at question 4. Question 4 says the reducing agent in a redox reaction is always the species that is. So we have been asked the reducing agent in a redox reaction is always the one that is called the reducing agent, is the one that loses electrons. So remember from the definition, reducing agent is a substance that helps reduce another substance but ends up being oxidized. Now if it ends up being oxidized, it means to say it loses electrons, because oxidation is the loss of electrons. It means to say it loses electrons. Also, since it loses electrons, and we know the principle is that as long as it loses electrons, it means to say the charge increases, meaning to say there is the increase in the oxidation number. So the answer for question 4 is both B and C are correct. Looking at the next question, it says in the reaction, which species is reduced? So we are being asked which species is being reduced. So just as I told you, reduced, just think of it as having a smaller charge. So if this is from 2 to 3, this means to say it has been oxidized because the oxidation number has increased. Now, since that's the case, automatically what will be our species that is reduced is our Cl2. So Cl has been it has been reduced. So the overall charge for Cl2 in this compound will be a 0. Just as I told you, if it's not showing it's 0, then here it has become negative, and -1 is less than 0, so meaning to say it has been reduced. So the species reduced is coming from the reactants is chlorine. Moving on, question 6. In the same reaction, the reducing agent is. So the answer for that one is since the reducing agent is the one that reduces another substance but ends up being oxidized, the reducing agent has to be this one, because it has been oxidized from 2 plus to 3. It means to say it has been oxidized. So that's the reducing agent. Don't forget the definition, very important. So looking at question 7, which of the following best describes the function of an oxidizing agent? So I repeat, the definition for an oxidizing agent is a substance that oxidizes another substance but ends up being reduced. So if it ends up being reduced, it means to say it gains electrons. Since the charge decreases, it means to say it gains electrons. So the gains electrons is only found here. So it gains electrons and is reduced. That's the definition that I have been talking about. So the answer for question 7 is B. Let's look at question 8. Question 8 says, in the disproportionation reaction of hydrogen peroxide to produce water, the element that undergoes both oxidation and reduction is. So if we look at this, we know from our knowledge that oxygen in peroxides has got a charge of -1. So now, if oxygen in a peroxide has got a charge of -1, then in other normal compounds such as water, it has got a charge of -2. So this means to say here oxygen has more like being reduced, since the charge has reduced. Then also in oxygen O2, when it combines with itself, it's more like the charge is just 0, it's just neutral. So this means to say oxygen in this sense acts as both as oxidation and reduction. So it means to say our answer for that one is oxygen, which is our B answer. Let's look at question 9. We are told that which of the following statements is correct? A. Oxidizing agents undergo oxidation. Oxidizing agent undergoes oxidation. That's not true, because oxidizing agents end up being reduced. Reducing agent undergo reduction, which is also not true, because they have to undergo oxidation because the charge increases. Let's look at our option C. Oxidizing agent undergo reduction, which is true, because I have been saying it over and over. So oxidizing agent undergo reduction, which is true. Let's look at question 10. So it says in the reaction aluminium plus copper, which the reducing agent is which one? So if we look at this one, reducing agent, the charge has to increase. So there should be, the reducing agent is the one that has the charge increased. So because it has to end up being oxidized. So the answer is this one. Since we are looking at aluminium will be able to become aluminium ion if it loses 3 electrons. So the charge has become 3 positive, meaning to say it has been oxidized. So the one that is oxidized is the one that we call the where it's coming from is the one that we call the reducing agent. It has to end up being oxidized. Let's look at question 11. We are told that in the redox pair Fe2 plus and Fe3 plus, the species that acts as the reducing agent is, so which one acts as a reducing agent? So looking at this one, it has to more like shift. Like let's say if it is Fe2 positive, it has to become Fe3 positive. That means to say the number has increased, meaning to say it's the reducing agent. But how about Fe3 positive? Can it become Fe4 positive? Certainly not. So the one that will act as a reducing agent is Fe2 positive, because it can be able to become Fe3 positive by the loss of 1 electron. So the reducing agent is our A. Let's look at question 12. In the reaction chlorine plus hydroxide to produce chlorine and the chloride plus we have water. Then we are asked chlorine undergoes. So how do we identify what chlorine undergoes? So here what we are going to do is let's look at chlorine in the first part. So chlorine, since the charge is not showing and it's only on itself, it's neutral, so it will be a 0. So it has become a -1. So this -1, since the number has reduced, then that means to say chlorine in this sense are being reduced. So chlorine in this sense is reduced. But how about here? So if you look at here, we have a Cl plus, or Cl and O. So here we know that the charge of oxygen is certain, so we can say chlorine plus the charge of oxygen, we know that it's -2, should be equal to the charge of a compound, of a charged compound is equal to the overall charge. So we are going to equate to -1. So we have chlorine, this -2 can be taken that side, so that we have -1 plus a 2. So Cl should be able to become +1. Now this +1, so it has risen from 0 to +1. That is the charge for chlorine. So if it has risen, it has become oxidized. So in this case, chlorine is both oxidation and reduction as our answer for question 12. Question 13. Which element has the highest tendency to act as an oxidizing agent? So the oxidizing agent, since it ends up being reduced, it simply means to say an oxidizing agent will gain electrons. So you ask yourself, from these options, which one has got the tendency of gaining electrons? Certainly it's a non-metal, which is very electronegative, which is our chlorine. Let's look at question 14. We are asked to say the species that donates electrons in a redox reaction is called. So for this one, the one that has the tendency of donating electrons is what we call the reducing agent. Why the reducing agent? Because the reducing agent ends up being oxidized. If it is oxidized, it means to say it has lost electrons. It has lost electrons. So if it loses, it's more like it's donating to another. So for 14, the answer is B. Question 15. We are asked to say which of the following is not a redox reaction. So we have magnesium plus O2 to become this. So in this one, it is oxidation, because here we have 0, here we have 0, but magnesium in here will have a charge of +2, -2, zinc to zinc 2+. This one, this to this is also a redox reaction. It's both oxidation and reduction. Then also for answer choice D, we have 3+ to become 2+. 2 plus to become 4 plus. So all of these are both oxidation and reduction. But one property that we need to know is that for a neutralization reaction, it is not a redox reaction because the charges do not change. So for this one, for 15, the answer is C, because this one is a neutralization reaction in which we react an acid and a base to produce a salt and water. This one is not a redox reaction. So the next part that we are looking at are the calculations. Let's look at the next question. So the next question says, the oxidation number of sulfur in hydrogen, in sulfuric acid. So for this one, we have the rule which states that for an uncharged compound, the overall charge or the sum of the charges is equal to 0. So this means to say, if we have the hydrogen, there are 2 hydrogens, which is specific, so we have 2. The charge of hydrogen for any compound is equal to positive 1. Then we add plus the sulfur that is there, plus what do we have for oxygen? So we have 4 oxygens times the charge of oxygen in other compounds except peroxide is equal to -2, should be equal to 0. So the overall charge for an uncharged compound is equal to 0. So we have a 2, then we have plus, we have 4 times, so we have S, then 4 times -2, we are going to have -8 should be equal to 0. So we have 8 plus 2, we are going to have the sulfur plus, a sulfur, we have 2 minus 8, we are going to have a -6 should be equal to 0. So sulfur should be equal to, we take the 6 this side, we are going to have +6. So the answer for question 16 is C. Let's look at question 17. It says that in manganese, in potassium manganate, we have the oxidation number of Mn is, so this is the same, this is uncharged, so the overall charge will be equal to 0. So we are going to have the potassium, since it's a metal in group 1, it will have a charge of +1, then plus the Mn, then plus we have 4 oxygen will have the charge of -2, should be equal to 0. So we have Mn, then we can add +1, then 4 times -2 is a -8, should be equal to 0. So Mn should be equal to 1, Mn plus -7 should be equal to 0. So Mn, when it crosses the equal sign, we are going to have a +7. So question 17, the answer is C. Let's look at question 18. The oxidation number of chlorine in MnClO3. So this one is also uncharged, meaning to say it is the overall charge will be equal to 0. So we want the charge of chlorine. So we are going to have, since sodium is found in group 1, it will have the charge of +1, then plus. What is our chlorine? Our chlorine will be, we don't know, so we add plus. How many oxygens are there? We have 3. Then what is the charge of oxygen? It is equal to -2, should be equal to 0. So we have chlorine plus a 1, then 3 by -2 will be -6, should be equal to 0. So we have chlorine 1 minus that, it gives us -5, should be equal to a 0. So chlorine should be equal to, when we take the 5 that side, we have a +5. So for the answer choice here is D. Let's look at question 19. The oxidation number of chlorine in potassium chromate is equal to, so here we are. So the oxidation number of chromium in the potassium chromate is dichromate is. So what do we have here? So we are going to calculate. So same principle. So we have this, there are 2 potassium, then since it's found in group 1, it will have a charge of +1. Then we also have the chromium ion plus, we are going to account for the 2, then we are going to say Cr. Then also we have 7 oxygen, so we have +7. The oxygen has got a charge of -2, should be equal to 0. So when we multiply this by this, we have a 2 by 1 is 2 plus 2 Cr, then we have minus a 14 should be equal to 0. So we have going to correct the like term, so we have 2 Cr minus 14 plus 2 should be equal to 0. So we have 2 Cr, -14 plus 2 gives us a -12 should be equal to 0. So 2 Cr should be equal to 12. Then we divide 2, Cr should be equal to +6. So our answer for question 19 is a C. Moving on to question 2. We are asked, in ammonium ion, the oxidation number of nitrogen is, so the overall charge, the sum of all the charges in a charged compound is equal to the charge on that compound. So for this one, we are just going to say we want the charge of nitrogen. So we have the nitrogen plus, how many hydrogens do we have? We have 4 of them. Since we have 4 of them, we have 4, then hydrogen has got the charge of +1, should be equal to the charge on that compound. If it's showing +1, it means to say the charge will be equal to +1. So N plus 4 should be equal to 1. So N should be equal to 1 minus a 4. So N should be equal to -3 like this. So we have N should be equal to -3 as our answer. So our answer for question 20 is 3. Let's look at 21. The oxidation number of P in H3PO4 is. So for this one, same principle, it has got no charge, the overall charge will be equal to 0. So we are going to say 3, since there are 3 hydrogens, hydrogen has got a charge of +1, then plus we have the phosphorus, then plus the oxygen, which is 4, it will have the charge of -2 should be equal to 0. So we have 3 plus P, 4 by 2, it will give us -8 should be equal to 0. So P plus 3 minus 8 should be equal to 0. So P, then 3 minus 8 gives us -5 should be equal to 0. So P should be equal to +5 like that. So the answer here is +5. Question 22. The oxidation number of oxygen in peroxide is. So in peroxides, the oxidation number of oxygen is simply equal to -1. So we can calculate that, confirm it by saying the charge on this compound is hydrogen. We are going to have 2. How many hydrogens? We have 2. The charge of hydrogen is 1. Plus the oxygen, which we don't know, we are going to put there are 2 oxygens, should be equal to 0. Since hydrogen is fixed, so we have 2 plus 2, 0 should be equal to 0. So we are going to take this to the other side. So we have 2 oxygens should be equal to -2. If we divide 2, oxygen becomes equal to -1. So the answer there is -1, just as I said. 23. The oxidation number of Mn in manganese oxide is. So for this one, we are going to do the same, the charge. So we have Mn in the compound, then we have +2. How many oxygens? We have the charge of oxygen, we have -2 should be equal to 0. So we have Mn, then 2 by -2 will give us -4 should be equal to 0. Mn should be equal to +4. So the answer there is +4. Let's look at question 24. The change in oxidation number of nitrogen when NH3 is oxidized to this easy. So let's answer this one. So we have NH3 to become NO2. So let's find the oxidation state of nitrogen in this one. So it will be nitrogen plus 3. Hydrogen has got a charge of 1, should be equal to a 0 since it's uncharged. So N should be equal to, we take this 3 this side, so we have negative 3. How about the nitrogen charge in NO2? It will be equal to, we have nitrogen plus there are 2 oxygens. The charge of oxygen is -2, should be equal to, since it's uncharged, it will be equal to 0. So we have nitrogen minus 4 should be equal to 0. So nitrogen should be equal to +4. So the answer here is equal to +4. So we have -3 to +4. So the answer here is a C. Let's look at the next question, which is 25. 25 says, in the compound of nitrogen sulfide, sodium thiosulfide, we have the oxidation number of sulfur is on average. So same, this is uncharged, meaning to say the overall charge will be equal to 0. So we are going to say there are 2 nitrogens and sodium. Sodium has a charge of +1. We are going to add plus the 2, we don't know the sulfur, then plus we have 3 oxygens, and oxygen has got a charge of -2. So this should be equal to 0. So we have 2 plus 2s minus 3 by 2 is 6, should be equal to 0. So we have 2s minus 6 plus 2 should be equal to 0. So 2s minus 4 should be equal to 0. So we have 2s should be equal to, we take the 4 this side, we have 4 over a 2 over a 2. So our s should be equal to +2. So that is how we do calculations. Thank you very much for watching my video. Hope you would subscribe, like and share for more. With this, you will have no problem with the introduction of redox reactions.